For the following exercise, determine whether the graph represents a one-to-one function. All right, so this is actually going to be very, very straightforward. In order to determine whether a function is one-to-one, you're going to use something known as a vertical line test. So all you're going to do, if this thing in blue represents your function, all you're going to simply do, draw some random vertical lines, all right, across the graph. If each of these vertical lines, let's say we're talking about this vertical line, if this vertical line only intersects the graph at one unique spot, then the function is a one-to-one function. All right. Now, technically speaking, all of these lines have to intersect the graph. All these vertical lines should only intersect the graph at one specific location. So since this vertical line also intersects just there, and this vertical line also just intersects here, no other spot, and you can kind of think, you definitely know what's going to happen. This thing is trailing on and off forever, right? In those directions, no vertical line that I can draw here will intersect that graph more than once. That is by definition now what a one-to-one function is. All right. In other words, let's say this x value here of 10 has one unique y value of -10. It doesn't have two y values. This x has only one y. That's 1, 2, 1. Okay. If the graph looked the other way, pretend you had something that looked a little funky, you had something like this. Well, that would look really funky. But if you notice, no matter how funky it looks, you see how this vertical line intersects two spots? That means now this x value of 10 has two unique y values of 15 and about 7.5-ish, 8, right? That is not 1-to-1 anymore. That means one x has now two y's. That's 1 to 2, all right? So hopefully that makes sense. Now, let's take a look at the second example. So you're going to draw your whole bunch of vertical lines. I'm going to draw this specific one right down the y-axis, okay? And we realize that, okay, all these other lines are pretty straightforward. This one only intersects here. This one intersects only here, right? This one I drew only intersects here. And this one I drew only intersects here, all right? But we might be looking at the middle one and you're like, oh, well, wait a minute, Andrew, doesn't that intersect here and here? Well. If this dot here was filled in, then I would say yes, because this line includes 0 and this line segment includes 0 as well. So therefore, the vertical line would have intersected two values, all right? But since this was not shaded in, okay, it was an open circle, what that means is that when x is 0, it only takes on a y value of 0. It does not also take on a y value of -5 there. So that being the case, this, just be careful, this vertical line now technically only intersects the graph at that spot only, because there is no point filled in there. So since all those vertical lines only intersect the graph once, then yes, it is a one-to-one function. All right, and same thing here. The function in blue was 1-to-1, and this function thing in majig in blue is also 1-to-1. Guys, thank you so much for tuning in. Hopefully that helped. Please remember to help us out and subscribe and hit that like button. I'll see you soon. Take care.